Let's look at part 4. Find the shortest distance from M, the midpoint AB prime to the line PQ. AB prime to the line PQ, find the shortest distance of M, the midpoint of AB prime. Where's AB prime? AB prime is here. Okay, this is AB prime, so you have the midpoint here, which is actually M, to the line PQ. I think it's pretty okay. Now, when it becomes more and more complicated, what I'll suggest is you just take the point out and the line out. That's all. The relationship now is just between a point M, which you can find, right? You can just use ratio theorem and find it because it's just a midpoint here. You can find it using the midpoint. Then you just take the line PQ out. Then you can actually find the shortest distance. All right. So we're gonna just do by using ratio theorem. So this is part 4. Sorry. So by midpoint theorem. Okay. So OM will just be equals to, remember, OM is a middle point, midpoint here. So it will be the subject. OM is OB prime times 1, OA times 1 divided by 1 plus 1 because this is ratio 1 plus 1. So by ratio, it's actually ratio theorem. So this is OB prime plus OA, okay, divided by 2. So I'm gonna just replace OB prime and OA in. I think it's not an issue there. OB prime is 3A, 2A, and A, right? So this is 3A, 2A, and A. OA is actually just 3A, 0, 0. So this is 3A, 0, 0. And this is divided by 2. This will be 6A, 2AA times half. Okay, this is OM. So now what we need now is the shortest distance of so I found OM already to the line PQ. PQ is this line which we found, so I'm gonna just draw the line PQ out. It doesn't really matter, okay, so just draw it out. So this is PQ, line PQ based on my formula here, which I use with A to AA. So this is P, right? A to AA is, that's P, right? I believe, yeah. A to AA and 362. 362 as the direction here. Okay, then you have got M here, which is half of it. So I'm gonna just, yeah, I'm gonna put this as 6A to AA. Okay, so if you want to find the shortest distance, remember, just draw, because now you have the vector of P to M. That is important. Then after which you have this direction here, which is this one here. All right. Now what we want is actually that distance here. So anything to do with distance, use the metric triangle. So this case here, the angle between these two vectors will be here. Okay, now we don't really care whether it's obtuse or acute in this case because the distance between them is essentially just modular. So we can just use this as PM, okay, cross or dot. So this is opposite. Opposite will correspond to cross product. Opposite in secondary school we learned this is sine. Okay, sine will correspond to cross. Okay, so this will be cross 362. Just take the two vectors and cross it, but you do not unit vector. Okay, the direction vector here is coming. This is D, so this is D. Then you don't unit vector the hypo, you unit vector the direction here. So that's about it. So the shortest distance would then just be PM dot with the unit vector. Okay, so I'm gonna just I think PM should be quite okay. PM side quest a bit. Just do the normal. This is 3A. PM is OM minus OP, right? So this is A and half A minus of A to A and A. That will give us 2A, negative A, and negative half A. Alright, so PM would just be 2a minus half a dot with 362 unit vector, so divide by its own length, 62 plus 2 square. Sorry, cross product. What am I doing? Okay, so I'm going to do cross product. Hi, goodness, it's cross product. 3 square plus 6 square plus 2 square. That will give us 49. That's a very nice number there because it's a perfect square. I'm going to do a cross product for the vectors on top. So this is minus 2 plus 3. That will be a. Then we got 4 plus 3 over 2. This cross product. So I am just doing a normal cross product here. If you're not too sure, please refer to this. You're supposed to know how to do it, so I'm not going to explain this part here. So if you want to mod the this part, this will just be this is square root square plus 11 over 2a square plus 15a square over 7. Wow, that would be 1 plus 11. So I'm not sure whether we need to find the exact value there, but we could just leave it like that. So plus 11 is not square plus 15 square there. That will be this is 1 over 7, and this will just be 1025 over 4a square. Of course, 10, this will just inserts. Oh my goodness. Okay, this is so painful to watch. So I'm going to split this, simplify this. So you can root the root 4 below. You get 1 over root 4, and you just root the. Okay, maybe I shouldn't skip like that. Maybe I just put it like that. This is root 102425 a square root a square is a. So that'll be good. 1025. We can try and see whether it could divide. Oh, there you go. Can divide by 25, which is a perfect square. That will be for. This is 2. 7 times 2 is 14. So perfect square, 25 and 41. A. So this will be 5 over 14. 5 over 14. Square root 41. A. Okay. So there you go. That's how units. So I'm going to put this as units. So that's how you do this questionnaire proficiently. If you have any question, please let me know. I think this is the part here. Great. Let's look at the subsequent part.